company that builds AI memory published their own benchmark table. Their system scored just under 67. Higher up the same table, the control group scored just under 73. The control group is the one where you build nothing at all and just hand the model the whole conversation again every single time. Doing nothing, 1. Now here is the line almost nobody quotes, and it is in the very same table. Their system reached that score using more than 90% fewer tokens, and at the slow end, it answered about 91% faster. So it was not a failure, it was a trade. And that trade is why the memory your AI actually uses is probably a folder of text files. Start with what memory is not. It is not the context window. The window is what the model can see right now, and it dies with the session. 2 episodes ago, we called that window a budget, and called writing something down one of 4 moves on it. This episode is the inside of that move. Memory is whatever survives after the window is wiped. It is also not learning. Nothing here changes a single weight. Every system here writes ordinary text outside a frozen model and reads it back. So picture a shift logbook. Nobody on the night shift ever meets the day shift. Everything that carries over is whatever somebody wrote in the book before going home. A survey this March put the mechanism in 3 words: write, manage, read. Read is the easy step, pulling the right page back before the model starts. Write is where the judgment lives, because something has to decide, at the end of a session, what from the last hour was worth keeping. Back in Season 2, we built exactly that loop on this channel: extract, store, recall on the leading open source memory system. The paper we opened with is that same team's. They published the row that beat them in their own table. Credit to them. That episode taught the loop correctly. This one is about what happened when the industry ran it at scale. Because the moment you decide what to keep, you have also decided what to lose. It is like writing the total at the bottom of the page and throwing away every receipt. If a later question needs one, no clever search brings it back. So where does the note actually live? Almost every explainer collapses 3 separate questions into one. Question 1 is what kind of thing gets remembered? Facts, past interactions, how to do a task. Borrowed vocabulary from psychology, not a claim about the software. Question 2 is the loop. Question 3 is the one that got an answer this year. Where does the memory physically sit? The research literature has spent 3 years on embeddings and knowledge graphs. Then look at what shipped. Anthropic's memory tool is 6 file commands against a directory. Their managed agent memory is a collection of text documents mounted as a folder. Their coding agent writes markdown files on your disk. And OpenAI's own agent framework, in its reference pattern, writes a memory file and a summary file. 4 shipping systems, 2 frontier labs, and not 1 vector index among them. 1 sentence explains the whole design choice. Switch that memory tool on, and the platform automatically adds an instruction to the model. It ends like this: assume interruption. Your context window might be reset at any moment, so you risk losing any progress that is not recorded in your memory directory. That is the shift logbook, written as a standing order. It is also the clearest reason the labs chose a file. A logbook you can open, read, copy, and correct is a different object from a filing system. Only the machine can open. This is not a slogan about Markdown. That same lab's harness report keeps its checklist in a stricter format, because the model is less likely to overwrite it. The substrate that shipped is files. Markdown did not win everything. Now the step almost nobody built. Agents write as they go, and those writes are local and incremental, so over many sessions a store accumulates duplicates, contradictions, and stale entries. That is the same lab's own wording. Their answer, previewed in May, is a background job that reads the store plus up to 100 past sessions and writes a brand new one. Duplicates merged, stale entries replaced. And the original left untouched, so you can read the rewrite and discard it. Picture the supervisor who comes in on the quiet day and rewrites the book. The lab named the feature Dreams, and the name fits. The book gets rewritten in the hours when nobody is on shift, and the old book stays on the shelf until you approve the new one. Here is the failure mode with no equivalent in prompting. Somebody writes a false entry in the logbook, in your handwriting, and every future shift reads it as fact. The security community now calls it memory and context poisoning, with its own slot in the agentic top 10. In May, a published demonstration walked through an ordinary developer morning: clone a repository, approve a dependency install. The payload reached persistent memory, the agent's global configuration, and the system prompt layer, and carried forward into later sessions. We have covered prompt injection on this channel. What those attacks never had is persistence. One injected instruction is a shout on one shift. One poisoned memory is a line in the book that every later shift reads and trusts, and the vendor's own documentation warns about exactly this. So does any of this hold up? 2 problems, and the first is scale. A benchmark accepted at a major conference this year pushes agent memory out to 10 million tokens, testing things like contradiction resolution and knowledge updates. On the leading memory company's own page, their system scores about 64 at 1 million tokens and about 49 at 10 million. Their words, roughly a 25% performance loss as context scales 10 times. The book works for a project. It buckles for a career. And notice what that does to our opening. The control group that won by pasting everything back in cannot even enter this race. At 10 million tokens, there is nothing you can paste into. The second problem is the measuring stick itself. 3 preprints this year, all unreviewed. The first swapped only the embedding model inside an identical pipeline and moved accuracy 6 points, enough to change which system wins. One variable flips the conclusion, in their words. The second points to an independent audit finding that in the most quoted memory benchmark, roughly one official answer in 15 is itself wrong, and an automated judge accepted up to 63% of deliberately wrong answers. A third, written by the makers of a rival system, reports completely different scores on the same benchmark under a different answering model. And a fourth, a survey this February said it plainly. Benchmarks are underscaled, metrics are misaligned, results swing with the model, and system costs get left out. Now the honest other half. The scores really did move. The system that scored just under 67 in our opening table reports over 92 today. What nobody has established is that it transfers to your work. So what do you actually do with this? 4 things. 1. If your tool keeps memory, go and read it. On the shipped systems, it is a plain file you can open, edit, and delete, and you are its only reviewer. 2. Keep it as many small focused files rather than a few big ones. That is one platform's own guidance. 3. Treat memory as instructions and lessons, not as a fact database. One framework puts it bluntly. Memory should help the next run. Remember how to work. It should not become a shadow compliance record. 4. Before an agent with memory reads anything from the open web, ask whether that session needs to write at all. On at least one platform that is a setting, and it defaults to writable. And here is what is genuinely unresolved. Extract at write time or keep everything and search it later, most of the literature extracts. The other camp argues that content thrown away before the question is known cannot be recovered afterwards, which is the receipt problem again. The file systems sit in between. The agent writes a note, but the whole file stays and gets searched later. Nobody has published a controlled head-to-head between the file systems and the index systems at production scale, so nobody can honestly tell you that files beat indexes. The first controlled study of file-based memory appeared only days ago, unreviewed, and its early read is the same trade as our opening. Organized files bought cheaper search, not better answers. What we can say is what the labs chose. And that same company's page this month admits the same gap, that judging one of these systems on your own workload is still a manual job. So until somebody settles it, here is the rule of thumb. The cheaper it is to keep the raw material, the later you should decide. So carry the shape. Memory is not something the model has. It is a loop the software runs around it, right? Deciding what is worth keeping and what you are willing to lose. Manage, merging duplicates, and crossing out what stopped being true, the step almost nobody built. Read, the easy one. Ask any memory product which of the 3 it actually does. And when somebody shows you a memory score, ask what the control group got. As of the middle of 2026, the biggest systems keep memory in files you could open. That may not last. The reason it happened will. This is episode 3 of Put AI to Work, our season on getting real work out of AI agents, 1 working skill per episode. The full free AI course is on the channel. Subscribe, and the next time an AI remembers you, you will know exactly where it wrote that down.